Hello, I want to introduce Nikola Kasabov. He is from New Zealand. He should be in Bulgaria now, but unfortunately he didn't succeed to come. But he will take his talk remotely, and I want to thank him for the support because he's very important person to us, and to give him.
Thank you, Dr. Dimitrov. Dmitry Dobrev. I will present my talk in lines of the conference, of course, which is responsible artificial intelligence systems. Can you see my slides now?
Yes, we can.
Sorry, I can see the slides. Well, it will be just a brief introduction, I think, talk. My talk is available as a PDF file. Anybody who is interested to have it, you can send me an email. I will talk about the AGI for the benefit of the humanity, and I would say only for the benefit of the humanity. Otherwise, there is no meaning of developing this. And I will talk more about brain-inspired artificial intelligence that can lead to better artificial intelligence for the human beings. Some of my presentation is in my book, which is called Time Space, Spiking Neural Networks and Brain-Inspired Artificial Intelligence. Of course, there are many definitions of AI, and we add some new functions to the AI systems, from learning adaptation now to consciousness, self-assembly, self-reproduction, etc., and social networks. And a bit of history of AI is always useful to know. And if we talk about starting AI as logic, that was Aristotle, who introduced this epistemology and knowledge-based systems. Of course, he also made mistakes, saying that women have inferior role in the society, and that was actually damaged lots of societies in Europe for many centuries. And of course, his work was continued as a symbolic AI. Then we went to Turing test for artificial intelligence that was also triggering quite a lot of interest and quite a lot of research in artificial intelligence. The question is, can machines think? And we are dealing with this issue now. Later, it came fuzzy logic. And this is the father of fuzzy logic, Lotfi Zadeh, who has been in Bulgaria, who has visited us in Bulgaria, also in New Zealand, and representing uncertainty in human thinking and human-like decision-making was very important to trigger new development in artificial intelligence. Then came artificial neural networks, and artificial neural networks actually brought learning to the systems. Here we have McCulloch and Pitts, here we have Amari, Shanichi Amari, and here we have the Nobel Prize winner 2024, John Hopfield, for his associative memory, where system can learn full patterns and can recall them with partial information. Of course, that was static information only, and the area still is developing. What is the current development of AI systems? We need to kind of classify them in order to understand them. We talk about generative AI, we talk about predictive AI, we talk about agentic AI, and we talk about AGI as systems with general human level intelligence. The question is, yes, we know all these systems are now being established and being practiced, but the question is how to develop artificial intelligence for the benefit of humanity. And my answer will be only a partial answer to this question because that's an open question. And I will say, first, we need to develop brain-inspired artificial intelligence, and we will see why. And second, based on this brain-inspired artificial intelligence, we can develop predictive intelligence systems. I call them PRIS, for the benefit of humans. And the question is, why brain-inspired AI? And how to do it? Well, brain-inspired AI they are artificial intelligence systems that are inspired by the structure and the functioning of the human brain. And the brain learns in time and space, highly efficient, low power, robust, predictive, explainable, high accuracy, and there are many advantages multimodal. We can actually enter both auditory and visual data. And also, if we work on brain-inspired AI, we can understand better our brains. And that is something that I will elaborate on. And the human brain, of course, is the most sophisticated product of the evolution in a lifelong learning, knowledge representation, knowledge transfer. And it deals with many types, 3 types at least, of memory and several types of time scales from nanoseconds to hours, many years of evolution. And knowledge is represented as deep spatial temporal pattern that can evolve, adapt over time. And how to develop, having the brain as inspiration, how do we develop brain-inspired so-called AI systems? Well, we start with the single neurons, artificial neurons, and we call them spiking neurons. And spiking neurons deal with spike information representation, which is a binary unit at a certain time. So time is involved as dimension of learning. And it departs the traditional neural networks, Hopfield and McCulloch, that dealt with vector-based systems. There's no time there. Now time is part of the system. It is in the data that feeds the neural networks, and they learn time of activity. And the brain is endless inspiration for such systems. For example, how do we deal with images? How do we encode images into spikes? Look at the retina, how it does it. It generates spikes every time the pixel changes. Look at the cochlea. It generates spikes at a certain frequencies. And there are many inspirations of how the brain turns the continuous environment into spikes. To deal with these spikes, and dealing with these spikes means learning unsupervised, and time is learned here in the connection weights. And space is where the neurons are placed. And also supervised learning, where we can train a certain neuron to emit a spike when a certain input pattern, spatial temporal pattern, is presented. But this is something very important, because this neuron can spike even only part of the pattern is presented. So this neuron has the so-called predictive abilities. We can build spiking neural network architectures, for example, 3-dimensional structure that is representing a brain template, and we can train it with brain data to see how the connections evolve. And that was the NewTube environment that I presented in 2014. And there is a development environment that everybody can develop their spiking neural network systems. And some of the systems can be implemented on hardware, which is called neuromorphic hardware, based on spiking neurons. So this NewTube is being used in almost 50 countries. I think you don't see the last ones, but they are very important. One is called United Kingdom, and the other one is called the United States of America. Well, how do we realize these spiking neural network models? There are different ways, from von Neumann principles and Jonathan Asuf, ABC computer, to neuromorphic computers and quantum computers. What are neuromorphic computers? Well, neuromorphic hardware platforms were developed, the first one in 1989, but now we have Spinnaker 2 by Steve Furber, Manchester. We have CHIPS, analog digital by Giacomo Indeveri. We have silicon retina, silicon cochlea, Toby Delbrook, and we have new developments as well. The most important is that the hardware offers high speed, low power consumption, and predictive qualities. It is not megawatts that a chip consumes. It is 20 watts. And this is the same as the human brain consumes because it's a sparse computing. Why predictive intelligence systems and how to do it? We can use this brain-inspired artificial intelligence to develop systems that predict events. For example, predict Alzheimer's disease and dementia. This is Alzheimer's disease of John Nash, and that was a movie, A Beautiful Mind. So if we get these systems to predict the event at its pre-prodrome rather than when it is too late, to predictive intelligence systems should do. And I call them PRIS, as predictive intelligence systems. Neuromorphic agents are also, they can be predictive. They are autonomous, making decisions, and they are still brain inspired because we can make a system agent that plays tennis or plays baseball based on how the brain does it, looking at the ball, reacting to the visual cortex, etc., and activating the motor cortex. And if you go to this website, you will see that the Sony agent, AI agent playing table tennis, won against the world championship. I can give you many examples of what we have done as PRIS, or predictive intelligence system, predicting dementia, for example, using 6 years data of people who are healthy, mild cognitive impairments or dementia. And we can, for a new person, we can predict 2 years ahead whether this person will develop dementia with 91% accuracy. Predicting stroke, predicting 95% stroke of individual 1 day ahead. Well, I don't have much time to cover all the details, but I have attached papers here, reference papers that can be followed. Predicting car crashes. I think agents can do that. Predicting the movement of drones and moving objects as airplanes. Predicting earthquakes. So here is New Zealand with 53 centers of earthquakes. We can train the system on previous data and see whether it can predict 1 hour ahead. The prediction of 91% accuracy of earthquake is a significant prediction. Predicting financial. Well, this is a system that combines both time series and online news. And this is online news are very important. You know that what Trump says now will affect a lot the financial market. And here we have some a diagram that captures how news affect different stocks. And this is a paper available free from Scientific Reports Nature. Anyway, what has Bulgaria offered to brain-inspired AI? So far, Bulgaria has done certain contribution. In 1990, we actually established the first school on connectionism and AI. Connectionism is neural networks. Then we have a special interest group on bioinformatics. A special interest group, we have a consortium on neuroinformatics, neural networks, and neurocomputers. They active now. And this consortium has the annual summer schools, and this year's summer school, 2026, will be in Plovdiv, just half an hour from now starting, and in Sofia on the 21st at the Technical University in Sofia. And you can find all the information here. And something more, people from members of this consortium have got funded projects from the European Union. One is for brain-machine interface and the other one for agents. And I should say that our consortium is the only organization in Bulgaria promoting and developing brain-inspired AI. So this is the European project we developed with Professor Koprinkova, and this is in consortium with European partners to develop spike-based systems to decode brain signals and control prosthetics. Another new project is the project that just started called Agentic AI, in which I lead the New Zealand part and also in collaboration with the Bulgarian part, which is Neuromorphica, small company by Yanni Trendafilov, and we work together to develop brain-inspired cognitive agents. Bulgaria's contribution has been in several areas, contribution to brain-inspired AI, for example, neural networks, symbolic AI, spiky neural networks, and current directions in brain-inspired AI are neurosymbolic, explainable, agentic, hybrid. In many ways, Bulgaria contributed not just to bigger neural networks, but to more biologically realistic and adaptive neural systems. And future directions, Bulgaria is positioned for artificial intelligence in neuroscience, and I talk about all this is for the benefit of humanity, for the benefit of humans. Neurotechnology, brain-computer interfaces, medical AI, and we can also talk about that its future influence may grow as AI brute force scaling shifts towards adaptive, explainable, energy efficient, biologically inspired, small scale AI systems rather than large language models. So the transition to this new type of AI, agentic, aligns surprisingly well with the traditions Bulgarian researchers helped develop decades earlier. And what is next? I would say that we need to combine knowledge from neuroinformatics, bioinformatics to make more biologically inspired and brain-inspired systems. Also, we may combine spiky neural networks and brain-inspired with quantum computation. And this is the first paper on combining which is called a hybrid spiky neural network quantum framework for spatial data classification. We have the quantum classifier along with the YouTube spatial temporal machine. And the future of AGI, well, it's my personal opinion, is brain-inspired AI for predictive intelligent systems. Integration of generative, predictive, and agentic AI through novel neural networks to help human decision-making and well-being. And I would also emphasize that the N3 consortium is the only organization in Bulgaria promoting and developing a brain-inspired AI based on N3 methods and technologies, which are again neuroinformatics, neural networks, and neurocomputers. And I'm very proud that I'm part of this development in Bulgaria. And I have some selected references. Anybody interested? I would like to thank Dr. Dobrev for inviting me. And I should say that I dedicate this presentation to my wife Diana. So посвещавам тази презентация на съпругата ми Диана. Благодаря. So I'm happy to answer any questions, or if there's not much time, I think we still have 5 minutes for questions, but if no time, I'm happy to answer questions through email, and to probably next time, if there is interest for collaborative work, I'm happy to see anybody who is interested to work with me on the new project, the so-called co-agent. Thank you.
Thank you very much. Maybe only one remark, and you focus so much on Bulgaria and general artificial intelligence. This is for all the humanity, not only for Bulgaria. And maybe we have to invite more people from abroad to join.
Yes, that is absolutely true, because there is no Bulgarian science there is international science, and this consortium, which is called N3 consortium, has half of the leading members are from overseas, and I should say that my experience is in Bulgaria. Of course, I have also experience in neural networks. I was a president of Neural Network Society, the international, the World Society. I was a president of the Asia Pacific Neural Network Society, and I have the kind of that gives me some information that I can share here in Bulgaria, because that is what we want to see our country developing and leading this brain-inspired artificial intelligence. Yeah, absolutely.
Okay. Other questions?
Well, if there are no questions, I'm happy to communicate on the email. And I have to open the school now in Plovdiv, the N3 Better School, at 9:30 Bulgarian time, and I will.
We lost the connection.
I will be back to this conference online to listen
Okay.
to my talk. Thank you. Благодаря много.
Okay, let's thank the speakers again.
Thank you very much.